Hey there, data people, and welcome back to the lab. Today we're gonna delve into CLI design and learn the basics of Cobra. We'll also cover a few details around our specific use case, like managing multiple HTTP services in a single serve command or serving a static site directly from Go using an embedded file system. We'll dip into TUI design with the charm stack, using lipgloss for styling and bubbletea to build a progress bar component for our CLI. And finally, for our Go tip of the week, we'll cover Go Work to set up a monorepo workspace, and we'll also show off a useful application of generics and type constraints in LabStore. Stick around! So on our previous version of LabStore, we used to have a backend package which contained the LabStore server command. Now we have renamed that to server, which is more explicit, and we have extracted the command and moved it to CLI directly. So now you only have binaries being compiled under CLI, in fact just one binary called LabStore. This is used for everything, to run our clients, to run our server, to start our service as a daemon if you want to test it out instead of deploying it via Docker. Now we also have a top level client module that implements the S3 and IAM client requests to our server, as well as some other stuff that was needed for this to work, like SigV4 client side. Since we now have three projects that depend on each other, the way we set this up was via Go Work. So if you want to do this on your own project, an older way to do this was to edit your Go mod, let's say for your CLI, and then you would add your module over here, something like github.com illumino labs LabStore, and let's say that we needed a server. You give it a version, sometimes 000, because it's an internal project, and then you use replace to replace this with your local version. Okay, so something like this. This is no longer the recommended approach, okay, and instead what we can use is Go Work. Go Work will create a go.work file on your repo root, and the way you init it is something like this. Okay, you can init it with some initial projects, but let's say that you just ran this for CLI, and then later you could use Go Work use and add the server, and that's it. So if you go into Go Work, you'll see only the Go version and your local projects. Each one of these will have their own Go mod and all that, but the integration happens at this level. Then you have to run Go Work sync, okay, and this will create Go Work sum with all the resolved dependencies, because each project has their own dependencies. They will be resolved here. I believe if something happens, some incompatibility, Go Work sync will probably show an error or something for you to solve. And so this is how you use Go Work. We also commit this to our repo. This is kind of optional to commit, but committing it lets everybody on the team work on the same dependencies, because you've got the Go Work sum, and also use all of this with your CI pipelines. So I believe committing Go Work and Go Work sum is the best option here. Finally, we also changed our building process. So now we only have make CLI, and this will pull all the dependencies via Go. This is our only binary, but CLI now depends on assets as well, which depends on web. and this is because we are going to embed our web UI, which is a static site, directly into our Go CLI, so that we can serve it via the embedded file system. And so we build our node project in web, then we run our rsync to copy the web build into our assets directory, and our assets directory will be under server, package, router, and in here you'll find a git ignore assets directory, which contains the files to embed, right? But we'll cover this later. Just a change to our build system. We also updated our GitHub actions for linting and testing. We now have a setup action that is shared between both of them. So this will check out the repo, setup node. We use the web package lock as the cache dependency path, so we can not have to download all the node packages every time. And then we install the dependencies using npm CI. We build the node projects, and then we rsync the assets into our server package, right? And we set up Go using Go work as our Go file version, and use the cache dependency path as our sum files. Although probably we should have used Go work sum here, just for consistency. And then, for instance, in linting, we just call our setup action, and then we install golang CI lint, and we run pre-commit, which calls the golang CI. So if you want to take a look at the pre-commit config, you'll find that we have a hook for each of the Go packages, one for server, one for client, and one for the CLI. And we need to call run with the same name that we defined on our Go work. So it needs to start by /server. If we try to use something like this, it won't work, because it will just show an error saying that, and I can show it to you. So if you do it like this, you got an error, does not contain modules listed in Go work, okay? But if you do something like client, then it will run without an issue, right? And this is just an implementation detail, but as you can see, it runs. And then we have test. Test also calls setup, and then it just runs go test. We didn't explicitly add a step to install the dependencies, because they are most of the times they will be cached anyway, so there's nothing to do. So if they need to be installed on the first time, go test will take care of that directly. And so we have a testing for each of these. And these are most of the changes that we did to our project. So now let's take a look at how we can use Cobra to build a CLI in Go. I really like Cobra. I've used Click in Python for a long time, and I think Cobra is a lot more mature than even Click. And it's definitely a lot faster, because as you add to your project in Python, you have so many imports, and either you deal with that and import locally, or your CLI will be extremely slow. So I almost think that it might be worth it to build a CLI wrapper directly in Go, even if it's for a Python project. But I haven't tested this idea in practice, so don't quote me on it. Okay, so let's go into the CLI project under command, and in here you'll find the main function and the main module. So we've got this init, which sets a global flag for Cobra. This enable traverse run hooks means that we have some persistent run hooks, and I'll go into details later, but this means that it will go through all of them instead of only the last implemented one. And so what we do here is we have this constructor that returns the Cobra command. This will be our root command, details to follow. Then we create a notify context so we can catch any control C interrupts, you know. And then we execute our root command using this context. And then we manually handle errors. So you can optionally return an error from each of your commands. What we do is we handle all of our errors within the command itself, so within our own logic. But in order for us to distinguish between internal errors from LabStore and some error that Cobra should print and handle into the terminal, right? We just use this runtime error type, which is just a placeholder, a flag, and if a runtime error is returned, we know it's been taken care of, so we just exit. And if not, we'll retrieve the command that's being run, and then we'll print the error and the usage for that particular command, which is more or less the default for Cobra. So now let's take a look at our root command. And as you can see, this is how you define a command. So essentially you are creating an instance of Cobra command, and we'll be returning this. The reason we don't return directly is that we have to set a few options after we create it. So you create this with use. Use will be the command name. For the root command, this is your application name. So for us, it's LabStore. This is why we are fetching this string, this constant. Then you can add a short description and an optional long description. The long description will only be shown when you ask for the help for the specific command or the usage for that specific command. When it's listed, you know, that small description that shows besides each command, it will use the short one. And then you've got several run hooks. And this is where you implement the logic for your command. If there is a subcommand or something like that, the command that is passed here is the subcommand, not the root command, okay? And so after we defined our root command, we can set a few options. We set silence errors and silence usage because, like I showed you, we handle that ourselves. If not, it would be printed even when we get our own custom runtime error. And then we can set flags and subcommands. Anything that's persistent flag, or you know, a persistent run or persistent pre-run, this will be propagated to subcommands. So in all of our commands, we'll have a debug, pprof host, and pprof port flags. This is so that we can enable our debug log, or enable our profiler. And then we have our subcommands. So we have the serve command, the S3 client, the IAM client, the admin client, which currently does nothing, and the upcoming TUI command. For now we are only showing the palette, so it helps us design some initial styles. And then we have our daemon commands, start, stop, all that. In here, let's get into the hooks. So we've got this persistent pre-run, and because we had defined that enable traverse run hooks is true, this will always run, you know, in order. So for any child command, this will run. This will be the first thing that runs. And in here we check for our top level command. If it's completion, then we do nothing, we return immediately, because we don't want to print anything for completion commands. This is for fish completion or bash completion, and this will output the script. So if we were to print anything else, it wouldn't be sourceable, right? And then we check for some annotations. These are user side annotations. So this is something that we set on our subcommands. And if our subcommand has show default secret set to yes, then we'll set this configuration flag, which means that when we don't have an administrator secret set, a random one will be generated for that session, and if this is true, it will be print. So we want that for server, for instance, but we don't want that for anything else. And then we also have the daemon mode, which is a bit different from our other Bootstrap code. Otherwise, we always run our Bootstrap code, which prints welcome to LabStore and loads our configs, initializes IAM, checks whether it must run the profiler and all that. So now let's go into IAM users, and if we go into new users create, we'll find one of our subcommands, one of the simple ones. So one thing that we did on the root command was set this handler key context with our IAM handler. So in this IAM main command, we are going to create a new instance for our client, and then we are going to set the context with this new instance, so that when we go to subcommands, we'll always have this available to us. So this is what we are doing here. We are fetching it, casting, and then we are running create user. As you can see, we've got this run e. For any run hook that ends with the suffix e, you should define the function and return an error. And this is how we handle errors. So for create user, there is an error, we'll print the error because we have got our own rendering methods for this, and then we just return an empty runtime error to signal that we've handled the error, and Cobra doesn't have to print anything. As you can see on our use entry, if we have positional arguments, we'll just list them here. These will be our positional arguments, and notice that we have got our args set to minimum n args of 1. So if you don't pass an argument, there will be an error. And just out of curiosity, we might test this. So if you go into LabStore, and we'll find IAM here. So IAM users create. Let's say that we don't pass any username. Requires at least one argument. Okay, only received 0, and you can check that it needs the username. Okay, if I send the username, I don't have the server running, so it will try to create the user. So now let's take a look, for instance, at the serve annotations that we send. As you can see, if we need to send any information to other commands to help us handle the workflow, we can do so by setting this map of string to string. So this is where we set show default secret to yes, and then this will be handled on our root command, as you can see in here, right? If it's set to yes, then it will set this before running config load. So just out of curiosity, this is the website for Cobra, the CLI framework that we are using here, and as you can see, this is well trusted in the community. It's used by Kubernetes, by the Docker CLI, by the GitHub CLI, and I mean, I completely understand that they use this because this is really well designed, and it's really efficient to implement a CLI with Cobra. They go through everything that I was just talking in here. So we've got this persistent flags, pre and post run hooks, command aliases, which I haven't used, or hidden commands, which I also didn't use here, and it's also POSIX compliant, which is great. So just a final one. So once we have our CLI built, then we'll automatically get at zero cost, you know, this completion command. And if we run this, you'll see that we've got this available for Bash, Fish, PowerShell and Z Shell. In my case, I'm running Fish. So for Fish, it will just generate this script. And before sourcing it, let's try to tab. And as you can see, by tabbing, this is a regular command line, regular terminal completion. So let's try to source this into Fish, okay? And now if we go in here, we'll get command completion at zero cost, right? Pretty cool, right? So let's start a server, and now let's, for instance, S3 service list buckets, and as you can see, our CLI is working. Okay. Now let's take a look at some details that are not directly related to Cobra, but are related to the process of building the CLI itself. So one thing we had to do was start several HTTP services when we run our server. And so I'm going to show you the way that we handle that. So if we go into server package router, we'll find that our router here has a server descriptor type, and this only takes a name for your server, the HTTP server, and an atomic boolean so that we can update this concurrently. That tells us whether the service is healthy. Has it been launched? Did it crash? And so what we do here is we create a descriptor for each service that we need. So our routes, for instance, for our server, which was already presented in a previous video, are now moved in here. So we've got our middleware, our handler set here, and everything is defined here. And when we run this new, it will return the server descriptor. The name is S3 compatible API. We got our server, which is the handler. We used to run this directly. Now we return a server descriptor. And we do this for all of our implementations here. We've got a particular one for the admin service, which takes a list of server descriptors. And this is because we are monitoring the health status from this service. Then we create this array with all the descriptors, and we iterate over them to manage all this. So the way we do this is we define an error channel where we receive errors from any of these services, and we define a wait group. For each server descriptor, we increment the wait group, and we launch a Go routine called run server, where we send the server descriptor, the wait group and the error channel. And once we start this, we set healthy to true. If there is an error, just since we are touching on this, if there is an error, this will be automatically set to false once it crashes over here. So this is run server. Once the server exits, we run wait group done. Okay, so it unblocks for this one. We print a message when we start with the name and address, and we just run the regular listen and serve. If there is an error, then we immediately set healthy to false, and we send the error into the error channel to be handled elsewhere. Okay, so going back here, we'll do this for each server, and this is non-blocking because it's in a Go routine. And we have other two non-blocking Go routines. So we've got shutdown servers and wait and close. So for shutdown servers, we immediately block waiting for the context to be done. So this is waiting for Control C essentially, because the context that we defined comes from this start over here. As you can see, there is a notify context that captures interrupt and sig term. Once the context is done, once the signal is received, then we'll shut down the server, and we've got just a timeout context in case it's taking too long. It will eventually exit. And so we go through every server descriptor and we call server shutdown. Essentially, that's it. Finally, the wait and close will be waiting for all wait groups to tasks to finish, and they are, as you can see, they are finished once run server exits. If we call shutdown here, it will unblock and it will exit here. And so once it waits for everything, it will also close the error channel, and this is to unblock the last loop that we saw in here. So we are iterating over the channel, so it blocks waiting for errors. Once the channel is closed, this will unblock and print all servers shut down cleanly. So let's take a look at how this exactly looks like. So let's say that we start serve. As you can see, these are all started in parallel. And once I press Ctrl C, the shutdown signal is received and each of these will be shut down. Okay. So we could do this as well using a signal. So let's say that we go here and we just pkill with just a regular sigint. Let's pkill LabStore. And as you can see, it got the signal and it shut down cleanly. So now let's see how we created our client and how we integrated. There is nothing really too complex about it. There's only some details that I will cover here. This is quite standard overall. So one thing we first decided to do was create a format to store the credentials on the client. We thought about integrating this into our existing config. So something like, that would be a part of LabStore YAML here. But we opted to keep this separate. It's just weird to mix the two things. And so the next question was whether we would use the same strategy that we used for config. So have a configuration file for credentials with command line argument overrides and eventually environment variable overrides for the client. At this stage, we opted not to do that, just because it's easier to, if there is some issue, to debug this using a single source of truth for the credentials. So what we created was this credentials YAML file, which uses the same strategy that AWS CLI does with profiles. So we can define several profiles. Each profile has an access key and a secret key, and then we set the default profile. In this case, it's set to default, so it will be the default admin credentials here. But you can, set it to admin or something else. The naming is your choice as long as it's default profile. And then when you run, for instance, let's just start LabStore, and when we run, for instance, this, we'll have a profile option. Let's say that we are going to try with admin, and as you can see, this fails. But if we use the default profile, which is running it like this, it will work. We can also just use profile default. It's the same thing. And this is how we implemented credential management. It's very, very simple. So now let's take a look at the general strategy we use to implement our client. So starting from the CLI package under our command, let's go into, for instance, S3. As you can see, we first initialize the credentials. So if there is no credentials file, it will be created for you. We just have to edit it after you run this. You can edit it manually as well. It's very simple. And so next we fetch the credentials. We either load the default profile or the profile if a profile name is given. And then we create a client instance with all of our credentials set here, and we set this with the command context so that we can use it on subcommands. So for instance, the subcommand for the service listing buckets will fetch the context and will run our handler. Our handler is defined within our CLI, so it's defined inside internal handlers. And in here you'll find that we've got list buckets implemented. The handler only contains a client, it's very minimal. And in here we'll call our client, and we also render anything using the charm stack. So we want to render a title, and you've seen this already. So when you run I'm starting this, and I'm running S3 service list buckets, and as you can see there is a title here, and this is what's happening over here with this render title. And we are also rendering each bucket over here, and so on our client this is a very simple HTTP client, except that we run our requests through our do sig before request, which we had to implement. This is essentially just the same as the server side, so there are some tiny differences, but it's the same logic implemented for client side. So some of the methods are even, or the functions are even reused from our server package. And so once we run this request, let's say we want to do get to the root directory, and this is just list all the buckets that I can access. Once we get the response, we'll check if status is okay, and if it's okay, then we'll parse this to the correct type. This comes from server. This is why we had to share the types to expose them in under package, and then we return, in this case we return the bucket, or if this fails, we'll parse the S3 error. This will largely depend on how this request is implemented server side. So if we go into our server over here and go into internal service list buckets, we'll go through this and check what types of results it can return. So one of them is list all my buckets result, or if it fails, it can also return an error, I believe. And here it is, an S3 internal error, it's a generic one. And this is how we handle our client. So we've got our command, we've got a handler that's called from the command, and we've got our client, which can be shared by other modules as well. So now let me give you a little taste of the TUI, and we already had to implement some components in here. So one of the things we started to work on was our palette. So the first thing we did was define which types of colors we would like to define for foreground and background, and we created this command just to help us, debug all this. And if we go into palette, which is defined inside render in here on the CLI, you'll see that we defined a palette type which sets lipgloss colors. This can later be used or extended to load color schemes if we want to do themes for our application. And in here we define a default palette with some colors. These are defined inline. And we set the active palette to this default palette, but in the future this can be used to switch themes, obviously. So these colors are defined for the terminal, so they can be 16 bits. And as you can see in here, we are only using 16 bits, but lipgloss supports 256 colors. And if your terminal supports true color, it will have these gradients as well, these well-defined gradients. Careful, if you are in Tmux, you need to explicitly enable true color. It's not enough to set xterm 256, so let me just show it to you very quickly. So in Tmux, we usually set xterm or Tmux 256 color. This is not enough to get that gradient effect. You need to set xterm 256 color RGB, otherwise you won't get it. You get more than 16 colors, but not the gradient effect, right? And so anytime a terminal does not support the 256 colors, lipgloss will take care of downgrading this appropriately, so it will never fail. It will always work. It might not look good, but it works. Okay, so this is where we create our swatch, the rendering that you just saw on the CLI. As you can see, there are elements from lipgloss like join horizontal or join vertical, and then you just, these render are just string creation functions, because as you know, in the terminal you have escape codes that are part of the string that set colors or reset the color, and this is how lipgloss works underneath, right? We also got, you can create your own styles, like you see here. You can set padding. These are inline numbers or character numbers, number of columns, number of lines. You can set a border. In this case, I'm using a rounded border, and even set some colors and foreground, background, and all that. And so, if we go into our metadata object, which is a helper object that we define, as you can see, we are defining some styles here. One way that is normal to define these styles is just use this method chaining approach: width bold set to true, align to the right, padding right 1 character, margin right 2 characters, background, foreground, and then just set this to render. So you'll be able to call this meta label style as a function directly. This is how they do it on their examples on the charm stack repo. For bubbletea, the progress bar, for instance, uses this approach. Sometimes you want to define the style without render because you want to use it as a base for other styles, and that's fine. This is, you know, if you want to use it directly, this is the way to go. And so in here, let's go into this particular example. We are defining this metadata, which will help us list a table of information. For instance, let me show it. So for instance, let me check if this is running, and it's running. So let's say that we want to ask for the head request for this object. As you can see, there is some metadata that is printed here, and this metadata type will handle this. So metadata is just a map of string to meta, and meta is each element in that table. It's got a value and a format function, because it might be a size, it might be a number, it might be, you know, a regular string. And this is what we are handling here. So we are created constructors, for instance, for date. So it returns a string that is already formatted. For size, and we are just formatting the number and adding a b for bytes. Okay. And then we have this special method over here, which is the first time I ever used generics in Go. I thought this was a good opportunity to test it. So we have this generic type constraint for number, and these type constraints only work with generics. So don't try to use this elsewhere, it won't work. And as you can see, this can be any of these numerical types, any float, any int, any unsigned int. And if you look at this, there is a tilde over here, which means that any type that derives from this type is also accepted. So let's say that we did something like my type, and this is a a float 32, then my type will also be considered a number. Okay, and if we go into new number, you can see that we get any value of type number that can be one of those floats or subtypes. This is not does not need to be called, so when you call new number, you just send the type. Okay, and this will return the meta. The meta just checks for floats and as printf the float with 6 decimal places. Otherwise it will print an integer, and this works for integers and unsigned integers as well. So this is a tiny helper method. We set this render to metadata, and this is why we create this type, such simple type with map string meta, just so that we can add a render method. As you can see, this is part of our render package, and this will essentially just render in order all the elements that I just showed you here. So another more complex thing that we did for the TUI was create a progress bar, and bubbletea already provides a progress bar, okay, but we also needed to add a place to store our logs, so kind of a tiny console, and we needed this to run not as the main program but asynchronously, switch control from the main program that is uploading, for instance, a file into the object store, and in parallel or concurrently update the progress bar without ceding control to the progress bar, as the main loop. So this is slightly different from the approach that is, the default for a TUI or demoed under the bubbletea examples. Let's look at our progress bar here. We use this bubbles progress as our default component. And as you can see, we define this model over here. A model must respect an interface that implements init, update, and view. We get the context. As a rule of thumb in Go, every time you have a context, just usually you will need to pass the context, because you need to know whether something happened that canceled the process, so we can exit cleanly. So we define our progress model over here, which is our progress bar. We set the max console size, because we'll have the console. If we don't have a maximum size, then this will be progressively slower, because we'll be keeping in memory a huge array of strings that correspond to each line in your console, and this is very slow to continuously render and keep in memory. So we need some circular buffer over here, and this is why there is a maximum console size. And we set this to debug or not, because we'll need to swap the logger so that we can redirect any logging requests to our console for this component. Otherwise this will mess up the command line. The TUI needs to have full control of anything that's being rendered at that moment, so we need to make sure nothing else is printed, otherwise it will mess up display. Then we've got our messages. We set this message called progress. These will be our channels, right? And we get the current value for the progress bar as well as the total value. We can change it on the fly if we want, but we usually don't. And then we've got a message to be sent to the console and a done signal. and some other helper variables like the program, which is the main loop for TUI in bubbletea. We get our console, which is the array of strings, the circular buffer, and we have this special console writer type, which will handle the swapped logger. We'll have this console writer, which will handle the writing to our component, our TUI component. So we create our new progress bar model, and then we create a program with this model. Then we have to run this program, okay? But first, let's take a look at what happens here. So we've got our init, where we just call bar init. Nothing else is here to be initialized. Then we've got our update. We'll get to it in a moment. And we got our view, which just does rendering. You see a lot of lipgloss here. So if there is something to render for the console, we just set the width to the maximum width of the terminal, so it wraps. And we just render it just like regular strings, okay? And then we also render our bar using calling mbar view. So view is rendering the bar, makes sense, right? And then just add a margin to the bottom, that's just it. And we join the two, so our rows will be the console, if there is anything in the console, and our progress bar. So for our progress bar, we get this update method, and this is your event loop essentially. And so for instance, when we get a progress message, we'll calculate the percentage to be shown. Then if the percentage reaches 100%, we make sure that it doesn't go beyond. It shouldn't, but just make sure. And then we return the model. It can be updated if needed, and you return a command to be run for bubbletea. In this case, we are running a sequence of commands, so we are running cmd, which is updating the bar to 100% in this case, or to the given percentage, and then we exit. Okay, we exit the program. In this case, we do not exit, so we don't need this T sequence. We do something similar for the console message, where we just handle the circular buffer and we set mConsole. This will be rendered under view. We also listen for keybinds. In particular, if you press Ctrl C, then we are going to quit. This frame message is for an animated progress bar. So instead of updating immediately, this is rendered from time to time. And these are frames. 60 frames per second, I believe, is what we set somewhere. And so this is how this is just straight from the example. So you just update the bar, okay? Then T window size message is just an event. When you resize your terminal, this will be called, and you can update your width and height internally, so you can keep track of it for your own components. That's pretty much it. The only difference is that we are from the examples is that we are using our own run method, and this is slightly more complex. So the way this works is we create this console writer output and swap our logger to this output. This method logger swap just returns a function that keeps track of the previous default logger, so that we can call revert and go back to the regular terminal logger. And then we create two Go routines that handle consume our messages, the progress updates and sends this to the program, and the console messages as well over here, okay, and sends it to the program. In here we start our program. Once the program exits these blocks until T quit, right? Once this ends, then we cancel the context for our progress bar. we wait for everything to end, all tasks. This means that, you know, once this is done, this will consume any remaining messages, and once this ends, it will simply return, right? And we'll call done. It's the same for both consumers over here. And then we'll revert the logger back to the regular one. So now we are printing a log message in the terminal as usual. And it's pretty much how we manage our progress bar. There are still some bugs to be fixed over here. This can be quite complex to handle all these channels and this workflow, just because, you know, this wasn't really designed to be used in this way. The idea is to start the program and then everything happens within the program event loop. In here we are trying to use this a bit differently, like an isolated component, but it seems to work. There are some bugs still, but I got it working without any issues, but then did some refactoring and some stuff is not working as it should, but it will be fixed in the future. Just an additional detail, if you noticed, we haven't used select before. This is not switch case, this is select case, okay? And what a select case does is it polls for one of the channels in the case and randomly picks one that is not blocked. If all of them are blocked, then it will go into the default option. If there is no default option, this will block until one of the channels gets a message. So this is how you handle multiple channel messages in Go. This can be quite useful to manage your concurrent workflows, you know, instead of the classical approach using mutex, you know, mutual exclusion. You use this workflow with channels, which is much cleaner than using that lower level abstraction instead. And finally, let's end with a cool one, a little cool detail. As you saw before, we've got our assets copied over here. This is the node project for the static site, and in here under web we define, we embed those assets. So you use this embed package from Go, and you embed the assets as an embedded file system. So all the files under assets, and then you can quite easily serve this using a file server from the HTTP package. So we just get the assets directly from front-end files, which is the embedded file system. You create the HTTP file system from this, and then you serve it using HTTPFS, and then this is a regular handler. And so this is a very simple way that you can keep your Go binary as a single file, you know, so that later we can run go install on this and a single binary will be installed, but it contains all the HTML, JavaScript and CSS as well that it needs to run the, you know, the UI. And if you take a look at this and run serve, you'll see I need to stop this. Just gonna run serve here. You'll see there is a web UI running on port 6790, and let's go into our browser to check for that port. So if I go to localhost 6790, I'll get into our placeholder SvelteKit web UI, and it should work. There are no resources as of now, but it should work as expected. Let's take a look. Just out of curiosity, let's take a look at how this is loading stuff. And as you can see, there is JavaScript being loaded already. Next time we'll get deeper into the charm stack. Today we used bubbletea to build terminal user interfaces. This was for the progress bar. And we also use lipgloss for styling. Okay. And next time we are going to build a proper TUI that will work as an S3 client and IAM client. And I'm excited to try that. And that's it. Hope you learned something today, or at least found this interesting. In the next video, like I said, we are going to focus on the TUI and improving user experience. As usual, this week's blog post is available at datalabtechtv.com. Follow the channel on Blue Sky for updates and join Discord if you have any questions, want to say hi, discuss something. Don't forget to drop a like and subscribe for all things data.